Okay, very good morning to all of you. First of all, just to say a few words of thanks. Mark has been very instrumental and has helped, I think, a lot in our, our learning and knowledge transfer of LabVIEW and so on. And also, first of all, also like to thank the NI team for giving me the opportunity to share and present in this event. All right, so today the topic of my sharing will be on this thing called the functional global variables. There's another thing which is not there, it's called the action engine. And another one will be the DVRS. So maybe can I just very quickly have a show of hands? How many of you have not heard about functional global variables? Just a quick show of hands. Not heard of, or action engines. Have you all heard about action engines? No, some of you may have. Okay, I see a couple of hands. What about data value reference, which is DVRs? Any of you have heard about DVRs? Oh, you have heard. Okay, so maybe some of you would be able to have some takeaways in my presentation. So first of all, just to move on, I would also like to acknowledge thanks to Nancy Hollenbeck for the permission. I saw her permission to share these materials. Actually, she presented this at the NI Week 2013 in US. Nancy is actually a CLA in US, and she's also a NI field architect. So she's a very experienced LabVIEW developer. All right. Of course, the title of her presentation was Everything You Ever Wanted to Know About Functional Global Variable. Okay, so my presentation will not only just have slides, I'll have some demos, which I think may interest many of you. Okay, now these are the original Nancy slides may be found at the NI website, or another website is this thing called the VI Shots. Anybody have visited this website? VI Shots, okay, some of you have, thanks. So the shot is actually managed by Michael Aviolotus. He's actually also a CLA in the US. So he does a lot of podcasts, interviews, and so on. So you may be able to get something by visiting this website and so on. Okay, so the agenda very quickly. So what is functional FGV in short, functional global variable, the benefits of FGV, race condition, something that we should really sometimes think about when we are doing our programming. Okay, race condition is a very true problem, okay, but how we can overcome it through the use of things like action engines. And then moving on to the next one will be this thing called the data value reference, DVRs. All right, so I think Mark shared very interesting insights about running applications where you have different modules running and trying to communicate. Okay, so you may have things like as shown over here, where you have concurrent processes running. Maybe you have a user interface loop, you have another loop that is running the data logging, and maybe the alarm notification and so on. Okay, but one of the key is also how do we interact or share data, okay, between these concurrent processes that are running, right? So the data storage mechanism, okay, has just now what Mark mentioned about things like local variable and global variables, right? So personally, for me, I would use it sparingly. I don't use a lot of these. As what Mark also mentioned, we might fail you will fail your exam, right? If you use a lot of these. Yeah, correct, okay. So let me explain a little bit more why we should try to not use so much of these global variables as well as local variables because of the issue of race condition, which I'll explain. Okay, so you can see over here I have many processes running, trying to access the data. All right, now the benefits of these FGVs are basically, for me, right, is to really to encapsulate the data. Okay, you need to use different methods to access those data. So in order to go into, you want to do some modification to the data, right, you have to go through a certain methods or the actions, if you like. All right, so now, FGV itself does not eliminate the problem of race condition, but action engine does, okay, which I will explain in a moment. So let's do a quick review of this functional global variable, a quick review. A typical sub-VI icon you would see will be something like this. Okay, very simply, you have a numeric indicator, for example, you have an output, all right, and then you have a set of actions. Okay, typically you use a type definition, enum, and so on, so you can control the different actions. Okay, So, okay, this is a general form. I believe many of the audience in this room have already used when you develop your sub-VIs in this kind of format. Now, any idea what is the purpose of this shift register? Any idea? What's the purpose? It's an uninitialized shift register, right? And the purpose is to store data. Yes, very good. Thanks very much. And you notice that this sub-VI, right, or I call it FGV, actually it so-called iterates only once, right? So upon, you can call these VIs many times, okay? Then you execute the cases. So a typical FGV, for example, if let's say you have a function like this where you have a set and a get action, right? So if you can set the values, okay, you can pass this when you select the enum, right, into the set mode, right? You're actually passing the data and you're storing it into the uninitialized shift register, and then of course you display it as well. And similarly, if you want to get the data, you can just switch it to the other case, okay, and you iterate it once. Now, I think in general, I think this one is a very common VI that many of you have already been using. And generally speaking, they tend to put the actions at the top of the VI itself, right? So I think there's a lot of benefit for this because it's kind of a self-documenting, right? As you can see. Now, a bit of quick history. Now, FGV has... Oops. Sorry. Is it okay? Yeah. Okay. Now, FGV has a long history. Okay, it's been called, LabVIEW to Style Global, USRs, and so on. Okay, and global variables, okay, or the introduction of variables, whether local or global, was only started in LabVIEW 3. Okay, I'm not as experienced as Mark. I only started to use LabVIEW when it was version 5. LabVIEW version 5. That was back in 1998. Yeah, okay. So it's been used extensively in the community, and also just now earlier Mark shared about this newsletter, right? LabVIEW Technical Resource article. Now, so in a way, what I'm going to show you here, I'll have a demo in a moment. This is a typical global variable that you would use, right? You can actually create a numerical indicator. You can do a read operation, or you can do a write operation to it. So you basically can read to it, and we can write to it. Okay, so we usually can create a set of wrappers, right? API wrapper to wrap this data around. So let's quickly show you a demo. Okay, now what you see here very quickly, over here, you can see that we have, oops, how to get it on the screen? I'm switching it to the LabVIEW. Sorry, how to show this? Okay, thanks. Oops. Okay. Okay, right. So what you can see over here, right? I have the block diagram, okay, and the front panel. And obviously, it is nothing really fantastic at this point, whereby, okay, you can create a global variable, right? One that is set into the read mode, another one in the write mode. You can actually pass the data and store it into the global variable, depending on what methods you use, right? So the idea is that you can create as many methods as you want, okay? All right, so if you do a quick run, you can see that you're actually passing the data and you store it to the global variable. Okay, so that's one. Okay, now, so instead of using the global variable, we can actually create this set get FGV, actually using the uninitialized shift register, right? So let's quickly take a look at this one here. Yep. Okay. So you can see that over here, we actually putting the methods, okay, inside over here. So where we can increment, we can decrement, okay, and you can do many things over here, right? But what this wrapper does, this get FGV does, is actually allows you to obtain the data, right? Extracting the data from the uninitialized shift register and passing it out, as you can see over here. Okay, sorry about this. Okay, now, so moving on. Now, but do FGV actually eliminate race condition? Okay, now maybe first thing first, what is race condition? Okay, now you may be able to find many definitions of it, but one of the definitions I like is that it's an undesirable conditions, right? Whereby the situation whereby a variable, right? Okay, is over the value on the local variable is being overwritten before it is being read. Okay, so it is a very undesirable situation. Okay, and you may be able to find some articles that talks about it. But let me show you a simple demo here. Okay, a demo which will maybe help you to illustrate this simple race condition. So over here, now the idea is this. Okay, now in this while loop, okay, you have a while loop that is generating a random number generator between 0 to 1. Okay, so what you're trying to do is we're trying to run a running accumulation to find the average values, okay, of this while loop here. So what you will see later on is that when I click the run button and I turn on the highlight execution, you will notice that because there's a race condition, the values of this local variable, okay, will be first read, okay, and then the value will be stored, okay, or remains at the wire, okay, before this division node can execute. Okay, now let's take a look. So if I turn it, okay, run this. Okay, you will see that initially when it first read off the value, right, the value of 0 is being read onto this local variable, right? Although the while loop is still iterating, the value is not finalized yet, right, as you can see, but the value is already on the wire itself. Okay, so when you click the stop button, right, you don't get the values updated here. Okay, the value is already on the wire itself, as you can see. So if I were to click a stop here, you will notice that, okay, the last value is 6.46, for example, but the initial value was being read off at the first instance. So your average output value is actually incorrect, as you can see over here, right? The average is 0. Okay, so that's just a simple illustration of a race condition. Now, I'm going to switch to another demo here, which is on this one, no race condition. Okay. Now, in this demo, okay, the idea is to execute the running of a single while loop, okay, and then to determine the number of iterations that this while loop has run. Okay, it's a very simple one. Okay, now, and at the same time, what we should be observing is that the values of these two indicators, right, the total iteration and this one here should be the same. Okay, so what I'm doing is that I'm just incrementing a value, a single value, each time the while loop iterates, as you can see over here. Right, so it gets the value So obviously you initialize to 0 at the beginning. So you 0, you plus 1, right? You increment, and then you store back to the FGV. Okay, so you can see that the moment when I click the stop button, right, these two values will be identical. So if I click stop, okay, it's the same value, right? So there is no problem of race, for that matter, because you are using this. There's only one instance of this FGV, okay, on the block diagram itself. So no problem, right? But what happens if you need to have multiple instances of this FGV? Okay, so what will you do? What is going to happen? Do you know by default, right, sub-VIs are set to non-reentrance? I think some of you may know, okay, right? So if you have two VIs running and you're calling the same instance of this FGV, right, there'll be some blocking effect, right, as you know, okay? You're going to get the FGV will be called. When this is called, this has to hold, right, and so on. So it's kind of like flip-flop, okay? So in effect, FGV, in this case, for the get and the set methods, right, it does not solve or eliminate this race condition. Okay, so let's have a quick look. This. So now the program kind of remains the same. We are trying to get the total number of iterations on these two loops. As you can see, I have a while loop 1, I have a while loop 2, right? So I initialize. The reason why I wire this here is I want them to start together, right? Because it's a data dependency, right? The data flow programming. So I'll start these two at the same time. So what you will see is that when I run this in highlight execution mode, okay, you will see that at any instance, the sub-VI, this get will be called, right? Okay, so the initial value was 0, so it's plus 1, right? Now, at the same time, before this 1 value is being stored to the set FGV, the 0 value came out. Do you notice? Do you notice there's this problem, right? So the point is that this method of doing it, you're not protecting what Nancy calls the critical section of the code, because you are modifying the data over here. Okay, so when okay, I'll just speed up a bit. I'll switch off the highlight execution. Okay, you will notice that the values are different, right? 102 and 151, for example. So because of the nature of this FGV that is being set as non-reentrance. Okay. So the observation is that race condition has been observed, okay, in this example. Okay, moving on. Now, the idea is to create this thing called the action engine, whereby you will encapsulate, okay, all the methods, okay, entirely into a single FGV. So you get, right, you will, if you need to modify, okay, and then you set all under one roof, okay, called the action engine, okay, as shown over here. Now, as what Nancy says, okay, now it actually protects the critical section of the code, okay, when you are doing the actions, okay, you modify, right, let's say you increment or you decrement, immediately the value gets back straight into the uninitialized, the shift register itself. Okay, so you will eliminate this problem. So I have a demo here to show you, action engine. Now these demos and my PowerPoint slides will be available for download. Okay, at the end of my presentation, I have a link in my Google Drive, so you can be able to download it as well. Okay, so you can see that I have this, right? Now, when I run this program and I click stop, okay, notice that you do not have this issue, right? Because the FGV takes care of itself, because this set into has a non-reentrance, right? So you don't have this problem of a race condition. Any questions so far? Maybe can I just ask anybody have any questions so far? No? Okay. Okay, so just to reiterate the point, the VIs are set to be non-reentrants by default. They cannot run simultaneously, okay? But the question is, what happens if you need multiple counters? Okay, 10 minutes. Okay, what happens if you need multiple counters or you need multiple timers in your application? What will you do? Maybe, can I ask Sophie? What will you do? Let's say if you need 10 of these counters, or you maybe have 50 processors running, what will you do? How do we make this? What will you do? Any idea? How will you solve? Let's say if I have maybe 10, okay, I have. Yeah, correct. This is the most common way of doing it. You would rename the VI, very good, right? But if you need 10 counters, you will probably have the same function but called different names, right? 10 times, right? Maybe counter 1, counter 2, and so on until counter 10, for example, right? And the other thing you might do is that you might change the icon, correct? This is a typical way that, most, people will do. I mean, I've done that before myself, okay? But there's a better way, okay? Let me share with you, okay? There's a better way called using data value reference, DVRs. Okay, now this DVR is very powerful mechanism because you are passing by reference, okay? Now inside the memory control application palette, you can find this DVR. Let me show you. Okay, you'll be able to find, okay, let me just pull this out. Okay, okay, if you right click on your function palette, right, if you go to applications, okay, there's this thing called the memory control. So you have this DVR, right, new data value reference. Okay, you have the constructor and the destructor, if you like. Okay, so what it does is this. Okay, it's a very powerful tool. I strongly encourage you to try. Okay, and you will see that you can create a reference. Okay, it's like a pointer pointing to the data that you are trying to use. It could be any data, it could be string, anything. Okay, array, especially array. Okay, now do you know that, maybe one more thing, do you know that if you have a array on a wire, right, and what happens if you fork the wire? Yeah, duplicates. And what happens to the memory? Doubles, correct? And what happens if you fork it more? Of course, the memory just keeps increasing until to the point whereby LabVIEW, the engine cannot handle, right? If your array is very huge, very large array. All right. Now, this is one way to eliminate the problem, okay, by using DVR, okay? There has this thing called the in-place element structure, as you can see over here. Okay, if you right-click on your here under structures, right, there's this thing called the in-place element structure. Okay, now let's see how this thing works. Very briefly, I think I only have about 3 minutes. Okay, so what happens is that you create a library, LV-lib. Okay, now you can actually create templates to the methods that you want to do. Okay, you need to have a certain steps. For example, you need to have the create. Okay, you perhaps have a count, that's for example, okay, and you want to get count and so on. So all these methods, instead of having a FGV with all the, or action engine with all the methods, right, in the different cases, right, you're actually tearing it apart, okay, into individual VIs like this. Okay, now it is a very powerful method because, okay, what you do is you are actually creating that, you are passing the reference. You don't pass the data, you pass the reference, okay. You use the in-place element structure to operate on the data, on the space itself, on the memory space itself. Okay, and then you put it back to the reference. Okay, so let's take a look here. I'll show you a demo. Okay, I have a demo here. Okay, now what it does is that this demo actually uses the event structure. Okay, what it does, okay, as I run this VI, okay, now you notice that I can create the counter, right, dynamically. Okay, so if I say I want to add 2 counters, right, I can increment these counters, right, or I can decrement if I want to. I can dynamically add another counter, or a few more if I like. I can increment, okay? So to me now, they are different counters. Do you see? So you're actually passing it the reference. Now, if you look at the code itself, over here, okay? Now, what you're trying to do is that when you do an add, right? When you try to add the counter, what you're trying to do, you're trying to build the reference. Okay, you build the reference and you pass this reference to this shift register in this while loop here. Okay, now when we increment, okay, because this one is set to enable indexing, the reference get passed into here. You don't pass the data, you pass the reference. So over here, this VI actually take care of the incrementing part using the in-place element structure. So if I were to very quickly show you this VI wrapper, so what it does is something like this. All right, so in this in-place element structure, you pass the reference to it, you will extract the data out inside the in-place element structure. Then you do your operations, right? Then you put the data back, and then you continue on with the reference. So that's the idea. So you're able to scale, right? In case I need 10 timers or 10 counters or whatever, you just operate it by reference. In this case, it's a very, very powerful mechanism. So I've used it quite a lot. Okay, so just to share with you on that. I think, okay, so the DVR demo. Yeah, I think I've come to the end of my presentation. I think I have about 30 seconds left or something like that. So if you have any question, feel free to also discuss with me over lunch. And I also have this Google link that you can download my demos and also the PowerPoint slides. Yeah, okay, and I also like to strongly encourage the community, the audience here, okay, to go visit some of these very useful websites. Okay, like the NI community, where you have forums and stuff. And of course, the one that I also like to go is to lavag.org, which Mark also have shared. Okay, you may be able to find a lot of useful codes and discussions going on there. Yep, okay, I think I've come to the end.